So first of all, most of you did pretty good on these, but be careful with the names. If you were going to use the names, they have to be exact. It's like an all or nothing. Like I'm not going to give partial credit if you use the wrong name. So if you're not 100% on the name, then you use the description. Okay, so with number 1, you can either say if diagonals are bisected, then it's a parallelogram, or it's the parallelogram diagonals, hang on, converse. If you do not give me that converse part, it's wrong, okay? You have to. So if the diagonals are bisected, then it's a parallelogram, or if it the actual name, which is the parallelogram diagonals converse. Santi.
So on the proofs, would we have to...
There won't be a proof on the quiz, but it would be like a tell how you, and you would have to. If this was a proof, you would get given that the diagonals are bisected. I would say maybe the proof has like a different step, like maybe the center is the midpoint, so then you have to show that they're equal, that kind of a thing. Test. I'm not answering questions about the test yet. We're going to do today for the quiz, and then when we get to the test review, we'll talk more about the test. Okay. 2 says, tell how you know the quadrilateral is parallelogram. From the information that is just there, you can't use a converse. I mean, you can't use one of the converse because there isn't one that says consecutive angles are supplement. If consecutive angles are supplementary, then it is parallelogram. What you can do is show that this line is parallel to this line, and that's the alternate interior. No, sorry, same side interior or consecutive interior angle converse. And then you can show that these two are parallel using these two, same thing, consecutive interior angles converse. So then it's a parallelogram by the definition of a parallelogram, which says that opposite sides are parallel. That's one way to do it. If you use the other method, which was adding up the sides and subtracting it from 360, you would have gotten this is 100, and then you can use the opposite, well, parallelogram, opposite angles converse, which says if opposite, both pairs of opposite angles, both pairs, opposite angles congruent, then it's a parallelogram. But you would have had to show that that last missing angle was 100 in order to do that, because that's how you would show that those are congruent. So 2 different ways to do it. Both were fine, but be careful because some of you did not give enough information. All right, third one said, for what value of x is the quadrilateral a parallelogram? Okay, 2x would equal 2x, but 2x plus x plus 30 has to equal what? 180. No. Yes. So 2x plus x plus 30 has to equal 180. So 3x plus 30 would have had to equal 180. 3x would equal 150. And x would equal 50. So some of you set them equal to each other, like 2x equals x plus 30. That's not right. It doesn't have to be consecutive. Don't have to be equal to each other.
Yeah, I thought it was like 2x equals 2x.
But you have to also, that the x is used again. That would be all real numbers. That would never solve. You have to use the other one. Okay, and then 4 says, in a coordinate plane, draw the quadrilateral with the vertices, and then show that A, B, C, D is a parallelogram. So A is -1, 3. B is 7, -1. 1, 2, 3, 4, 5, 6, 7, -1. C is 6, -4. 1, 2, 3, 4. And D is -2, 0. So just drawing it is not enough information. There are 2 ways to figure this out, okay? One way is to show, well, 3 ways, really. One way is to use the lengths. If you use the distance formula on each side, which would be a pain in the butt, but if you use the distance formula on each side and you showed that the opposite sides were congruent, that works, right? That's easier for something that's horizontal or vertical because you just count them. For this one, I would say avoid that, but that is a way. So you'd have to show, using the distance formula, that AB equals DC and AD equaled BC. That's one method, and that's the one I would avoid. The second one is show that the same pair is congruent and parallel. So I could use, again, the distance formula on either AD and BC and then find the slopes of AD and BC. So I could show AD is equal to BC and AD is parallel to BC. Or I could do AB and DC the same way. And again, still tedious because you still got to use the distance formula. The third and easiest way to do it is find the slopes of these lines. Yep. So if I find the slope here up 1, 2, 3 over 1, this is 3 over 1. Do the same thing here, 1, 2, 3 over 1, that's also 3 over 1. So I've got one pair of parallel already. And then the other ones, I can go 1, 2, 3, 4 down, and 1, 2, 3, 4, 5, 6, 7, 8 over, or 1/2. And do the same thing here, 1, 2, 3, 4, 1, 2, 3, 4, 5, 6, 7, 8. And the slopes are the same. So AB is parallel to DC and AD is parallel to BC. And you'd have to show the slopes. Like you can't just say they look parallel. You can't just say they look the same length. You'd have to then prove it by showing the work of those. Yes.
Where you find the lunch schedule?
Oh, good. Okay, so quiz on tomorrow is 7-1 to 7-3. In 7-1, you need to know all the names of the polygons from 3 sides to 12 sides. So triangle, quadrilateral, pentagon, hexagon, heptagon, octagon, nonagon, decagon, dodecagon. Remember, there's none for 11. You have to know those. If you don't know those, obviously you need to study those. Yeah, 11 gone. Anything else is just that gone. Then you need to know the sum of the interior angles, which is n minus 2 times 180. You need to know the sum of the exterior, which is what? It's always 360. You need to know each interior, and this would have to be of a regular, which means all the angles and all the sides are congruent. And this would be n minus 2 times 180 over n. You'd need to know each exterior, again, of a regular polygon, which is 360 divided by the number of sides. And then the variation on that was what if you're given, so finding and given an interior, well, one interior angle. And for that, you would set whatever value they give you equal to n minus 2 times 180 over n, and then you'd solve for n. So whatever value they give you, and then finding n, given an exterior angle. And for that, you do 360 divided by the angle.
Is that all?
For 7-1. Yep.
Oh my gosh.
All right, then 7-2, we have the properties of a parallelogram, which were, we started with the definition of a parallelogram, which is opposite sides parallel. So all of these are a quadrilateral that has blank. So a quadrilateral with opposite sides parallel. Then you had parallelogram, opposite side theorem, which says opposite sides are congruent. You had parallelogram, opposite angles theorem, which said opposite angles are congruent. You had parallelogram. What am I missing? Consecutive angles. God bless you. Theorem,
God bless you.
which says consecutive angles. God bless you. Are supplementary. And we had parallelogram diagonals. Theorem, which said diagonals bisect each other. Again, 5 total things. The first one is the theorem. The first one is the definition. 5 properties. All right, then 7-3 was the reverse. So these were all the converse. I think I just took a picture of it because I'm getting lazy. Which said that, and again, there were 5 ways, which are these, okay? 5 ways to prove a quadrilateral is a parallelogram. The first is to show both pairs are parallel, and your reason there would be the definition of a parallelogram. The second way is the parallelogram opposite sides converse, which says both pairs of opposite sides are congruent. The third is opposite sides are parallel and congruent. So that's the opposite sides, parallel and congruent theorem converse. This one's missing the word converse. Converse. Oh, no. Just kidding. That one is not a converse. Sorry. If it's one pair opposite and congruent, then it's just the original one. The fourth one says show both pairs of opposite angles are congruent. That's the converse. And the fifth one, both diagonals are bisected. That's also the converse. But again, if the names are what's throwing you off, just know what it says. Questions on content before we get to an example? Okay, so the question came up, what happens, how do you solve the n minus 2 times 180 over n? I'm going to give you an easy example because I don't want to duplicate what's on there.
Did you do 7.3 yet?
Yes.
Oh, I missed the picture.
It's because you're watching soccer, so I'm not going to go back. If an interior Okay, so finding the number of sides if they give you an interior angle. One, it's got to be, again, a regular polygon. So if it gives you the interior angle of a regular polygon is blank, find the number of sides. So let's just say, and again, I'm going to pick an easy one because I know this isn't on your quiz. Let's just say it's 90, right? So I would get n minus 2 times 180 over n equals this angle. So it would be n minus 2 times 180 over n equals 90. And then I got to solve it. So I would multiply both sides by n. This is going to cancel. Marcy, with me? I'm going to distribute the 180. 180 n minus 360 would equal 90 n. I got to subtract the 180 n. Negative 360 would equal negative 90 n. And then divide both sides by that negative 90. So it won't be this one because hopefully we know this one. Okay. But that would have 4 sides, which would make it a what? What's the name of this? Quadrilateral. It can be a square, but it doesn't have to be. Over n. Yeah, and if it gives you the number of sides, you just plug in for the n. But if it gives you the angle, you got to set it equal to that. And then you got to work backwards.